Hello everyone. In this video, we'll quickly review on the step how to generate a raster data out of the point data. In GIS and remote sensing, there are cases that the data is not provided in the raster form, and instead it is provided as a text file. This text file can consist of the information about different kind of parameters from temperatures to depth, elevations in the case of LiDAR, or in this case, in the Chinook Lake in Brazil, the data we have is about the depth of the lake, right? So I already talked about that in class earlier. We have the data for two lakes that you can see on the screen. We have the Chester Lake, which is on the upper part here, and the Warm Lake, which is on the lower part here on the images. And if you look around the area, you see that we have three lakes: Chester, Warm, and some other lake, which is connected to the other two lakes, right? But from here, since we don't have any information or any data about this lake down on the bottoms, so we're gonna skip that in our study. Also, as far as you notice that we only have a couple of points that was collected to have the information about the depth of the lake. However, we don't have any other point to define the lake boundary, right? In that case, the work that I'm requiring you to do is, since we know that this data was collected back in April 2018, so you may want to go to the website called you may want to go to the earthexplorer.usgs.gov, and then you want to go to terahertz, and in the terahertz area I already define my study area here. So the Chinook area is go to the east part. It's in between terahertz and Brazil. Down here, you just start defining a polygon to cover your area of interest, like the way I define in here. And after I define it in the search criteria using this, I want to go to the result options and pick the number bracket to be maximum either 25,000 or 10,000, so that I'm going to achieve the maximum amount of output. Otherwise, if you just define the amount of output to be 100 or 500, it's going to just have a limited amount of data that can be acquired. Also, before you start downloading, I want you to go to the dataset and define the elevation model in here. In the dataset part, you want to go to the digital elevation group and select either CONET, GMT, or IPSAR. The data that we may want to use is CONET and GMT, which is the elevation data for this for almost everywhere in the world. And there are a couple of different data portals that provide the elevation data. One of the very common one is the ASTER-derived DEM. The ASTER-derived DEM will have the spatial resolution of about 30 meters. Also, you want to go to Sentinel and select the Sentinel tool in this earthexplorer.usgs.gov, and now just go for results, and we can show the result in here. If you quickly look at the images, you will see that in some images it is densely cloud covered, right? We don't want them. And since I didn't define the date of acquisition, I need to get back. So the date range, now I need to define it. The date range should be somewhere from April 2018 on the first date, right? That is May, April 2018, and then it should be ended by somewhere around May 2018, right? And then I'm gonna pick May 2018, and then I'm gonna pick the last date of May. So I just go for my output. So on the result here, it shows all the images that was acquired in the area, covering the area that I defined it. So far we have 13 images. Some of them have cloud coverage. We just visually check and see whether the image for our area look good. Like this one, which was um, acquired back on uh, May 23rd, 2018, which is good. So I recommended you to download these images down and use that image to help you defining the boundary of the lake on that date. And if you look at what I am having right now on here is I add the Google Satellite Hybrid. If I go for properties, they show the information about my layer, but I don't have any other informations. It just shows that the image was collected. Let's see whether we have any kind of information about the date of acquisition for that images. Nope, we don't have any of them here, right? No historical, no reference, nothing. So that being said, with the background images of the base map like we add on here in QGIS, there's no way for us to define the actual time of acquisition of these background images. It means that the boundary here, it is unknown. The time of this boundary is undetermined. So you will need to use your the Google images, or no, sorry, not the Google images. You will need to use the Sentinel images that you download earlier here, and then place them. You can use any band of these images, and then place them on here. Add them into here as a background file. So now, that is how. Let's pretend that we are having that Sentinel as the background in here. But indeed, in this case, I'm having the Google Satellite Hybrid. But in your case, you will need to have this background file as the Sentinel images acquired on May 23rd, 2008. So now the next step that we need to do is we are having two separate files, one for the gesture and another one is for worm legs, right? We need to merge them all together as one single file. So we go to vectors, we go to no, I think, where is it? We go to vectors and then, oh here, sorry. We go to vectors and it is in data management tools. We go to merge vector layers and then we want to select the gesture and the worm leg as the input file, and we want to merge these two files all together, and we want the target CRS to be this, the projected EPSGs, not 1983, and then it is in UTM zone 16 north for the Indiana, and then we want to merge them, and we want to save it as a file. I want to save them as a CN, stand for Chinook, lake, and then SHP. So I already did it. So after I merged them, I have the CN lake file that is shown in here. And then the next step that I need to do with my CN data, as you can see, compared to the previous data, previous gesture and worm leg. For now, since we already have the images that was acquired on the date, which is nearest to the time that we collected these point data, that gives us the information about the water level of the lake and also to help us defining the boundary of the lake on that date. So we want to work with this CN lake data, and we want to go to this icon, the toggle editings. You want to click on that until you show that this triple pencil current edit appears, and also triple dots appears on the screen. So that's how you start activating the mode to allowing you to edit and to add more points to your data file. So I want to click on these triple dots and and start clicking on following the boundary line or the shorelines of the lake. And each time I keep adding 1 point, it show me an actions and everything will be new in here. Since I add my file, which is the merge between the Chester and the Worm Lake, so I would have all of these film is the merge or the combination between the two files, Chester and the Worm Lake. And the field that I need to fill in the information is the depth in meters. In this case, all of my depth representing for the lake boundary would be at elevation 0, right? I want to leave the ID blank. So I just keep adding a series of those points. And I want to follow them. You want to zoom it in to a certain level that you can clearly see the boundary. You don't need to zoom it for too much, and also you don't want to zoom them at too far so that you can hardly see the boundary. So just keep adding those points, and then make sure that you fill in the value 0 here. I already did for that, and I remember that by the time I came down to the field, these two lakes was connected. But from this time period, it is no longer connected, right? It means that from your images, it should be appear as black here, because at that time we have high water levels. So just keep adding those points. And until this point, you see that I have my depth data just up to this area. And we have no other point for this, right? And we want to keep adding our 0 points to completely cover this range, and it should follow this area, should cover the two dots that I have earlier. And then now we want to stop it at here, but we still have some other points of 0 to cover this part and go a little beyond and outside this spatial extent of these depth points, so that I will have my depth value. So for now, you see that we have some kind of a peninsula in between the two lakes. So you want to define the boundary for that, for 0, to follow that area also, and then just follow the lake boundary until you completely cover this. Just keep adding 1 point and then go for OK. If you want to, the way I drag this map is I press on the scroll button on my mouse. If you have a scroll mouse, that's how I press on that, hold it, and keep dragging the map. That's how I drag the map to the area where I want to start digitizing. So in here, I want to cover this part. This is my point, and this is my point with the 0 elevations. So just keep adding those points. So I already did for that. I want to cover everything in here. You may want to notice about this depth point. I go very near to the shorelines. The shorelines is underneath the tree canopies. So make sure that you add some points which go beyond the spatial extent of these depth points, so that we can define the 0 point for the shorelines. You can also add 1 point somewhere down here, and then now keep following this track. And remember that we want just to limit the lower boundary of the lake just to be here, down here. So I already add a series of another points representing for the 0 depth. So I keep adding 0. So now I'm done with my points, right? I want to save them. So you want to go to this icon with a pencil on top of that to save the edit that you have made to your data. And you may want to open the attribute tables of these files so that you can see. So in here, we already add a bunch of the point representing for the depth value with 0, right? Oh, I just accidentally click on them and then I give them as 0, as null. I don't want any value to be null in this depth empty. So I want them to be this. And if I accidentally make them as null, I don't want to. For this depth column, you want to scroll it down all the way down until you see that we have some kind of the layer in the JSTOR, which was previously in a separate file called JSTOR, with the relevant information about the depth in these depth M columns. Like in this case, I have the depth to be 2 meters from the surface. So I have everything, right? In this case, the ID does matters. So any information in here should be good. Just leave them as blank. So I'm good for now with this JSTOR link. So point data. So the next step I want to do is I want to start interpolating this point data into a raster file representing for the pixel with different levels of depth for this lake. The way I do it is I will go to here. There are two options for me. Either I go to interpolations and then I want to pick the heat map, IDW, or team. But in this lab, I only want you to review for I only want you to review for the IDW, stand for inverse distance weight interpolations and kriging. So you may want to run this IDW in the interpolation tool. We want our vector file to be the CN lake, right? We want the interpolation attribute to be the depth in meters, and then we want to add them on here as the point data. You want to leave the distance coefficient P to be standard. If you change this P, it means that the value from the nearest point will have a either stronger or less effect on the way you interpolate the information about the point that you don't have any kind of information about the depth. So you also need to define the extent in here. I want to define the extent to be my current layer extent of these Chinook Lake. So I want to define the pixel size. Remember, in this case, because I already translated, or I already projected it into UTM, which is in the projection of the coordinate system that I can measure the distance. In that case, the unit of measurement in here would be the same as the unit of measurement in my original file, which is in meters, right? So I want them to be 1 meters of x and 1 meter of y. I want to give it a name as idw.s dot. In this case, I already make one. So you want to name it as idw and just leave the file extension blank so that it will automatically give it a name as idw.s dot. You want to save them and then you want to start running. After you run it, you should have one file something like this. As the IDW file, like the one that I'm showing on here. You see that, oh, here, good, right? Those point with this circle around it, highlight in yellow the point with the 0 depth, and those point with a dark blue mean it is the deepest point in the lake, and the other point with the light blue mean it is shallower, at a shallower depth. And that is one algorithm, IDW algorithm, that you can apply. Another IDW tool that you can go for, which is the one that I introduced to you in your lab, which should be in Saga GIS. This Saga tool is a pretty good tool, GIS tool, to help you do different GIS analysis. And in order for you to do your task, you want to go to Saga Raster Creations. In this Raster Creation tool, here are the place you have different options for either distance weight, angular, or inverse distance weight interpolations. This inverse distance weight interpolation is a lot similar to the interpolation tool, the default interpolation tool in your QGIS, but you should definitely try this one. I am trying these inverse distance weighted interpolations, and I want to pick the CN leg. The attribute should be in depth matters. I want to make sure that the distance weight should be in no distance weighting. No, I don't want it to be exponential. I don't want it to be Gaussian weight. I just want it to be inverse distance to a power. This power means it takes the information from a point with a known value of depth nearby. So I want to also to define, to make sure that I have the exponential to be in here. The search range should be search radius. I want my number, the number of my points should be all the points within a search distance. In here, the default searching value is 1000. You can change it to 50 or something. In this case, the distance between my points, if you want to look at that, the distance between the depth point in here, if you want to measure it, take the measure tool here, measure lines. You want to measure from one point to the next. It is about 45 meters, 40 meters, right? So it should be good if you define the range, or like the distance to search in this inverse distance weight is to be not 1000, but it should be around like 100. And then search for every point in that. You want to search for all the points within the search distance. You want to leave these minimum points. This is the minimum amount of points and then maximum amount of points around it. In our case, since we don't have many data points, so you can leave it as default 20s, or you can change it to either 5 or 10s. Also, you need to search mode to go into all the direction of quadrant, but we want to go for all the direction. We need to define the output extents to be as the layer extents, as the not the boundary. We want it to be Chinook leg. For the cell side, the default setting is 100 meters, right? We want to make it as 10, so that it is equivalent to the spatial resolution of the Sentinel images that you already downloaded. In the target grid system, in here you want to go for user define. We want to feed by node and the cell. In this case, the node is exactly the location of those points, so we want to feed it by the node, right? We want to target the system, which is optional, so we're going to leave it blank. We want to save it to a file. In this case, I already saved it and I run it as idws saga.s. Again, I don't want to define the file extension. I just give it a name and saved it. After you saved it, and then you want to go for run. After you run it, it will generate another IDW called saga. And in this case, if you want to compare them, let's see. I'm having my IDW, which is in here, IDW saga and then IDW, right? My other IDW, after I interpolate it using the standard built-in interpolation tool from here, IDW interpolation, it was interpolated as a vector file. So from here, I will need to export them and save the layer as a geotiff. And as the geotiff, I want to save them as you want to name it idw.tiff. You don't even need to put in a file extension, but I suggest you do that. And you want to make sure that the CRS should be in the coordinate system that we want. From here, we do need to define our resolutions to be 1 meters and then 1 meters, right? horizontal or vertical resolutions. So we want to leave everything out blank and then go for OK. It will add the file on here. And the TIFF file that I already make, I export out of these, the IDW is here. You will see that it's correspond to some this is the raster data of the depth of the lake, what we call the bathymetric maps. And then in order for you to change the color ramps, you want to go to properties and symbologies. In here, originally it was in the single grayscale data. Just show it something like this, right? So if you want to make it become more fancy, you can play around with this pseudo color and then change it and pick different color ramp. The first one on top is the first one on is blue. So we want to pick the blue one, but if I pick the blue, it is something like inverse. It means that intuitively I want the deeper points to have the darker color, right? But in this case, it gives my map as the deep dark blue as the shallow, equivalent to the zero depth, and the white one or lighter tone equivalent to the deeper points. You can change and play around with the color ramp, but in my case here, I will just pick a color ramp called Vivid. You see that this represent on the left hand side represent for the lower range of the value, and on the right hand side, so I'm going to pick Viridis color ramp. So that's how I have my map like here. If you compare the map, the IDW from the traditional already built-in interpolation tool from QGIS with the one that I made using Saga Raster GIS in here. On top, you see that it is slightly different if I keep changing between them. The one that I generated using IDW seems more reasonable. How? How so? If you look at the base map, if I turn out everything, you see that in around this peninsula, just temporarily call this part a peninsula. Okay, so we have an elevated area which is from 10 to 100 feet from the water levels, and this bushes area is more elevated compared to these water bodies. But in the case of IDW, you see that it somehow match it, right? It somehow assume that the flat area on here, this flat area, is at equal elevation with the water bodies. But in the case of IDW generated from Saga, it mapped that part better, somehow better. Also in the surrounding part, if we go along the shorelines, we also see that, which is, if we go further north, we see that it is more elevated area. That is from IDW Saga tool, it's generate a better output. So it means that what can be learned from here? It means that you shouldn't always rely on the default setting from the tool, and you should always check for the option that you have to generate your raster out of the point data. Also, another tool I want you to play around with from this lab, which is the ordinary gridding, regression gridding, simple gridding, or universal gridding. This gridding tool, it may give you better output depending on the way you set your parameters, because the gridding, it used pretty much the similar algorithm like IDW, which means that it will assign weight to those depth value from the surrounding points that we have. But also with gridding algorithm, it will do a little bit beyond that, which is it will take the spatial autocorrelation into account. So what does the idea of spatial autocorrelation have in this case is that if you look at this, if you look at the IDW data, it seems like the similar things tend to stick or stay together or clustered together. So it means that the depth point seems to be clustered around here, and the elevated point seems to be clustered around this area. It means that in geography and in geology, kriging always, not always, I shouldn't say not always, it means that kriging can't, sometimes it can provide a better output than the IDW. But it's up to you. You can play around with IDW and you can also play around with kriging. But if you play with kriging, you remember that you need to define, beside all the parameters you need to define earlier, you need to pick for type of quality measurements. And in this case, if you choose these logarithmic transformations, the output will no longer be ranging from 0 to minus 45 meters from the surface. It can be something else because it was transformed in a logarithmic scale. Also, you need to define for the output, you want to define the cell size. You need to feed with the nodes, the search range, the number of points should be all the points, and the search direction. We need to wait. And in here, the search directions. But with kriging, it's always want to create a quality measure file. You can skip the output and just save the file for kriging. I already have some kriging out here. So that is the first part for generating the raster file out of the data. But in here, another step, you see that in the later in your lab, I require you to create an overall map of the area, which consists of information about the height and about the depth of the lake, this lake, right? That being said, we will need to have the DEM for this area, right? So originally, if you download your DEM, the only information you can have is for this kind of water body is just this water body will have the zero value, representing for the zero elevation, right? Or at some certain level of elevation from the ground. So it means that you will need to crop the raster file that you already defined previously, right? So you will need to generate or create another boundary. So I want to go to raster, create new raster called new shapefile. This time I want a polygon. I want to give it a name that I already did. In my file I call it lake boundary, right? So I want to define it, and I want to make sure that I use the UTM zone 16 meter that I defined earlier. So I pick everything, and then I want to go for OK to create a new file. So now, since I already created, I will just add that vector file on here. The boundary in .shp as my shapefile. So I have my boundary, not this point data. I think my boundary. So let's go ahead and create a new file. New file called lake. I want to set them as a polygon data. Pick this and then hit OK. So now I want to start working with my lake data. In order for you to start editing any kind of the file, you want to start to select it down here on the layers, and then click on the pencil icon. So now, because my file is a vector file, the polygon, so it will appear as a polygon instead of the triple dots like we can see before with the point data. So I want to start creating a frame that covering this area. You may want to go to zoomed in more so that you can have a better outlook of your lake. In my case, it's just for demonstration. I just zoomed it in at this level. So I want to go around. So that's how I define my lake. In the final point, in order for you to finish it, you want to right click. You want to show the ID for this. Just leave it like null. So that's how I define my the boundary. For this, what do I want to do? I want to use this kind of frame to erase and crop. But in this case of if you use that in QGIS, it's called extract by mask. It means I want to extract this raster file using this mask, and then with this mask later. For now, I'm just change it so that you can see it better. I want to make it become more transparent, like how. Okay. So for here, my output would be something that has inside this polygon, but consists the information from this raster. That's my purpose. I want to go. The way for me to do it is I want to go to raster, and then I want to go to clip raster by extents. So with raster by extent, I want my original raster to be IDW Saga, because as we already discussed, the IDW Saga is better, right? So I want it. I want my raster to be the clip extent to be. Oh no, I don't want it to be the extents. Probably I want to, let's see, clip raster by mask. Sorry. So we have the input raster to be the IDW Saga, and we want the mask to be the lake that I defined earlier. We want to make sure that we enforce the target CRS to be in UTM. The source, we don't need it. And then we want to keep everything, keep resolution of the input raster, X resolutions. You can set it into 1 and 1 if you need to, if you want to, not need to. If you want to, but in this case we don't need it because I keep the resolution as the input file. So I want to name it something. Saved it as new lake.tif, and then I want to run them. Good. I have my new lake.tif now. That is something I need for this. So for now, later, after you have your DEM, I think I have finished downloading my DEM. Okay, good. I have downloaded the raster file and the DEM. So the DEM that I download also from the earthexplorer.usgs.gov. It's from the search, and then I'll download it from GMT. Oh no, not GMT. It's CONET. What is it? It's IPSAR. Oh no. Did I pick it? I didn't pick it, right? I select it, and then it's result for now. Probably we don't have any kind of DM around this time, so for DM we're gonna expand it into anything from that day until today, 2020, and then result if SAR, GMT, and then CONET. No, still no. I want to change the data set into this SRTM. Search, and then I want additional criteria to be CONET. Search data set. I want set it to be anything from any time in the history. Oh, strange. I just download that DM out from here, but previously I set it for everything from the dataset and the search criteria to be any time in the past, all the way from the past to the current. Because with the elevated area, we want to have any kind of data that is available to us. So this GMT file was collected back in, it was in 2010, right? So I'm gonna unzip that file. I want to copy it and paste it into the folder where I store my data, and then unzip it. If I plot it as the base of this file, and then I want to move the new lake on top of that, and let's see, change the pseudo color to be something, still using the vivid color pattern color RAM, and with other ones you may want to mosaic these separate five all together. Probably you don't need to. Let me see. Okay, you can change the pseudo color again, this time because we will represent for the height, right? So we can pick something different color RAM, like it should be white and then more red. Where's my lake? That's my lake data. I want to zoom it into that layer. Yeah, so because I have different color RAMs, so I'm representing here all the way from 63 minus 63 something until 9000. In order for you to make this color RAM work, you want to extract or crop. So you want to create another shapefile, and then in this shapefile you want to call it new frame SFP, and then the polygon data, and then for now you really just need to draw a areas to be surround the area you need. That's how you have your overall polygon. And with this new frame, use that frame, and then now you want to crop and cut your elevation data here. You just want to cut it. After you cut it to be within this spatial extent, and then change the color RAM. But right now, if you check the information, you will see that it is, the unit is in degree, right? And it is not in the coordinate system that we want. So you can transform them into something like this. If you transform them, it's basically disappear, because you will need to go to projections and then transform, warp it. Not the way I did. The way I did was I unfox them, so I make them disappear. And another step that I require you to do in your lab is to create a color composite images. So in order for you to create a color composite, here's the image of the area, the Sentinel-2 images of the area that I already downloaded. So I want to extract them, and the tool that you need to create the color composite image is SSP, or semi image classification tool. this thing, semi-automatic classification tool. And after I extract all the images, I want to go to the band set and load in all the images in here. For Sentinel, it should be in these folders, and then here we go to I think granulite, and then LC, and then IMG. Yep, here are all of my images, 5. Pick on everything except the TCI one. So it said that it requires to convert it from this WGS 84 to the destination WGS 84 UTM zone. That's fine. So from here we have all the images, right? That is shown on top of everything. I have all my layers. In order for me to pick the relevant color composite images, I want to go to Landsat color composite, and then it gives you any things like in Landsat color composite, or here pick on the first one, color composite. Like if we want to look at the agricultures, if we want to look at the land and water, we want to use the band 5, 6, and 4 for Landsat 8, right? And then for Landsat 8, so now we want to know that which band we want to pick the corresponding band from Landsat 8 and match it with Sentinel-2 spectral bands. Sentinel-2 spectral bands. So we have the Sentinel-2 spectral bands here, which show like band 1, 2, 4, 5 all the way until 12. And we don't know the spectral bands for 8, right? We need Landsat 8 spectral bands. For Landsat 8 spectral bands, we can pick it here. So we have it. This is for Landsat 8. And previously from esri.com, we have the a perfect, not really perfect, but a good band combination to differentiate between land and waters, which is 5, 6, and 4, right? 5 is near infrared, 6 is shortwave infrared, and 4 is red, right? We want to pick the same thing. So we want to pick the 5 near infrared. So near infrared, it means we pick 8. And then shortwave infrared, it means 8, 11, or 12, 8, 11, and then 4, right? That's how we pick our color composite, 8, 11, and then 4. So from there, the way we do that is we go to band set again. So now we want to go to basic tool, and in the basic tool we want to load all the combination possible, and then we want to pick for it's got frozen, sorry, not responding. We just need to keep waiting. So we want to go to basic tool and scroll it all the way down until we have the band 8, 11, and then 4, 8, 11, and then 4. Good, right? And then we want to, so that's how we already load it. In here we have a similar range of band, the red, green, and blue. That's how we represent it. So we pick the 8, eight, 11, and then 4, 8, 11, and then 4. So that's how I displayed my data for this lake. Where's my lake? It is in I want to zoom the layer here. So here's my data. You can see that it's kind of blurred, right? Because I'm overlaying a multiple different layer on top of each other. But that's basically how you overlay it and make your and then after that you want to export it and save a layer as a tier 5 and maintaining that orders. Another way you can do it is just create a one image is stacked, but it's not required also. Since we know that 8, 11, and then 4 are the good band, right? So to make it and to run it for the raster, we want to go to the working folder where I'm storing it. And then I will need to use the library called raster. And then I want to read in like band 4. I want to call it to the raster and then read in something equivalent to band 4.gp2. But for GP2 we can use raster. I think we can use read in GP in R. So in here we can read it using, I try different functions and not magics. What's that? I will read it using read OCR or GPEX. Yep. Read OCR in R. Here is how you read in those the OCR DSN layer. So instead of using raster, you can use read OCR, but also from but for read OCR you need RCDON library. So basically the way you do it is you want to go to R and then you want to go for first you need to library through that RCDON. And then for now I just make up that like band 4 as equivalent to read OCR something blah 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 for band 4.jpeg2, and then I do the same thing for band 11s, specified it to band 11s, and then the last one would be band 8, right? Band 8 as band 8, something like that. And from here we want to use a stack function in raster library. So we need to call the library called raster, and we call them like red, green, green, blue, 8, 11, and then 4 to be stacked. I want to stack like how? I want stack band 8, and then band 11, and then band 4. That's how I basically create a stack file of the similar color composite like the one I made in QGIS. And then I want to use the right raster, and then in the right raster, if you see it in here, not mosaic, I want to right raster, help package equal right raster. No, there's nothing. So I want to write raster. You see that it required me to give it an X file or file name or something, right? It means that from here, since I already assigned my color composite image to be equivalent to a variable called RGB 8, 11, and then 4. So I want to refer it to red, green, blue, 8, 11, and then 4. And then I want to give it a name. This name can be named anything like your last name is, let's pretend that I write it for my the name under the name of my professor, Dr. Stone. it would be stone, and then it would be red, green, blue, 8, 11, and then 4, and then dot .tif, and then hit enter. That's how you write the file. But make sure that in your lab you pick on the proper path, working path, and folders to the area where you store your file. Thank you for your attention.